Okay, for 16.2 and 3, I ended up combining them because they both are talking about pollutants. So when you end up using fossil fuels and other things and putting them into the atmosphere, or into the water or ground, they can be considered a pollutant, and that causes problems with the biosphere. So pollution is any undesirable factor added to the air, water, or soil. Smog is an example of air pollution that you end up finding. Many of you have probably seen this if you're driving into a larger city like Chicago or Indianapolis, or LA is a good example. You will see a brown haze in the distance over that city as you're coming to it. So the sunlight is going to interact with the pollutants in the air. Pollutants produced by are going to usually be produced by fossil fuel emissions when we're talking about smog, and made of fine particulates and ground level ozone. Ozone's a good thing when it's way up in the atmosphere, but when it's down at breathable level, it's not so good. So, and right over there to the right-hand side, you'll see what the smog looks like when you're looking at a city. So smog can be harmful to human health. Another thing is that smog can help cause is acid rain. And acid rain is also caused by fossil fuel emissions. So it will end up, it's going to be produced when pollutants in the water cycle cause the rain's pH to drop. So when it drops, that means that it's becoming acidic. So that is what the acid rain is. Many people think of acid rain, they think of like it lands on you and you're like, "Psst, I'm melting." And that's not what it is. You won't just going out in the rain. It's probably acid rain that you're out there in, and you really don't know or notice the effects of it. But it can lower the pH of lakes and streams. It can also harm trees. So when all of those things happen, it's going to end up having effect on your ecosystem. Something that you may notice around buildings and things like that is the acid rain will break down the limestone and stonework on the buildings and cause them to deteriorate. So like when we were out in the graveyard, you probably noticed that a lot of those tombstones were hard to read. That is because of acid rain. So high levels of carbon dioxide in the atmosphere are going to end up the levels of the atmospheric carbon dioxide are going to rise and fall over time. When you get high levels, the Earth is generally warmer, and you can see this from the graph there. So the red is the carbon dioxide, blue is the temperature, and it goes 400,000 years ago, 300,000 years ago, 200,000 years ago, 100,000 years ago. So you can see that the Earth has gone through a natural heat wave, cold time, heat wave, cold time, heat wave, cold time. And you can see right here that we are on a heat wave. We're increasing our average temperature, and our carbon dioxide is also going up as well. When you get a lot of carbon dioxide in the atmosphere, you end up with what's known as the greenhouse effect. And the greenhouse effect slows the release of energy from the Earth's atmosphere. The greenhouse effect, a lot of times you hear about it and you're like, oh, it's bad. It's not a bad thing when it is appropriate, like when you don't have too much carbon dioxide in the atmosphere. So without the greenhouse effect, we'd be 20 degrees cooler today than what we would be. So it's definitely a good thing. It keeps the planet fairly warm. So it allows the sunlight to penetrate the Earth's atmosphere. These greenhouse gases do, and the main greenhouse gases are going to be carbon dioxide, water vapor, and methane. So the energy is going to be absorbed and re-radiated as heat. The greenhouse gases, they're going to absorb longer wavelengths of light, and the greenhouse gases molecules release the infrared radiation. So the idea behind it, if you've ever gone out to a car that's been sitting out in warm temperatures and all the windows are up and you open up that car door and you feel like the wave of heat when you go to get in, that is the greenhouse effect. It's going to allow the sun's energy in and through, but it's going to trap that heat behind. So that is a bad thing if you get too much of these greenhouse gases in the atmosphere. It can cause the temperature to raise pretty quickly. So the global warming refers to a trend of increasing global temperatures. And once again, you can see on this graph, you've got the temperature in blue, the carbon dioxide is in green, and the carbon dioxide is continuously going up, and you can see the average temperature on the planet is also increasing as time goes on. You can see the pictures of what the ice cap used to be like and what it is currently. So moving into section 3, the pollution of the Earth's fresh water supplies, they're going to threaten the habitat and health of the ecosystems. Pollution can put entire freshwater ecosystems at risk. So indicator species provide a sign of ecosystem health. So amphibians are a good example of a indicator species, and there's one that's not looking too hot. Your top predators are other signs of an indicator species. So if you end up having issues with like them being able to reproduce and things like that, it could be because of something in that ecosystem causing issues. One thing that happens is what's known as biomagnification, and that's going to be the accumulation of toxins in a food chain. So pollutants can move up through the food chain. So predators eat contaminated prey, and it's going to really build up quickly in those predators. The pollution accumulates at each stage of the food chain, so the top consumers, including humans, are most affected. So you can see down here, you've got the phytoplankton, and you've got parts per million, so there's a pollutant that they picked up. And then the zooplankton eats the phytoplankton. The smelt, which is a small fish, is going to be eating the zooplankton, and it's now at part 1 part per million. And then the lake trout eats that smelt, and it's now got that chemical at 4, almost 5 parts per million. And then if that herring, if this gull ends up eating the lake trout, the eggs of that gull are going to have 124 parts per million of whatever pollutant it was that we're talking about here. So it ends up building up really quickly. So pretty much any fish that this gull is eating is going to have that pollutant as a part of it. So that's why it builds up so quick. So that is the end of the notes for sections 2 and 3.